Hello everyone, welcome to this second C1 booster session on indices. Today we're going to look at two different types of problems. The problems you can see here, where we've got a string of algebra that we need to simplify down with the help of the index laws. And secondly, we're going to look at evaluating powers like you can see here. The thing I want you to bear in mind with example 1a is how flexible multiplication is. We'd much rather do 7 times 5 first. We can multiply these in any order we wish. Next, I'd rather do x squared times x cubed, so that's what I'm going to do. Next, we'd rather do y times y squared, and then finally consider the z's at the end. Well, actually there's only one z term there. So we can do 7 times 5, 35, but then we just need the help of our index law, which we should have all met, and that says that when you've got the same base, so in this case x, and you're timesing, we can just add our powers. So that's how we simplify the rest of it down. We don't need these multiplication signs. We're just going to write x to the 2 plus 3, y, and we've got 1 add 2, so y cubed, and we've got our z cubed. B is a little bit trickier and can get very messy. You can write it as a fraction, and when we write things as a fraction we can often see simplifications a bit more clearly, as we'll see. Because now we start thinking of our equivalent fractions. We can divide something into the top, that's fine, as long as we divide the same thing into the bottom. So we could divide the bottom by 6, and that goes in once. As long as we divide the top by 6, that's fine. We can divide the bottom by x, as long as we divide the top by x. We could divide the top by y cubed, as long as you divide y cubed into the bottom, which means this power is going to get reduced to a 2. And we can divide the bottom here by z, as long as we divide the top here by z. So that gets reduced to a 3. Now you can see the disadvantage of this method is it does get a little bit messy, so we've got to be very careful reading back the answer now. But on top we've got a 7. The x just got reduced to a power 1, that y cubed has disappeared entirely, and that z has gone down to a cubed. Now on the bottom the 6 has gone, but we still got the minus, but we can position the minus on the bottom, on the top, or just in front of the fraction. And I'm just going to position the minus here. So the 6 has gone, that x has gone, that z has gone, all we've got left is the y squared. And that will be the simplest form. Alternatively, we could recall our index law to help us do the question in perhaps a more direct way. Let me just take a copy of that. So instead we could just do 42 divided by minus 6. There we go. Then consider your x terms, x squared divided by x. Because we're dividing, we need to minus our powers, which is why we know we're going to get 2 minus 1, just a normal x. Next we consider the y's. We've got y cubed divided by y to the 5. Now the dividing means that we're going to minus our powers, so 3 minus 5. So it's going to be y to the negative 2. Finally, we've got z to the 4. We are dividing by z, so we minus our powers, so it's going to be z cubed. Of course, you'll observe that we've got something slightly different than what's there, but we don't really, because this term we can write as 1 over y squared. We can ditch that negative as long as we then write it on the bottom. So they are indeed equivalent. So two sort of different ways to approach that problem there. Now what catches C out is students get fixated on this bit here and they start perhaps recalling how to do that, they'll think about this index law and they'll think that we need to multiply those powers together and get x to the minus 6, and all of that is true. But do bear in mind also that it's the whole thing that's being cubed. So we must cube the 6 and we must cube the x minus 2. We've got to do both. So we cube the 6. Now perhaps we don't all know 6 cubed. We know 6 squared, of course, is 36. If we take 36 and times by a further 6, well, 36 times 5 is 180. And if we add on a further 6, it lands us on 216. Next, we do act on this bit. We do use the index law here to help us. It's telling us to multiply our powers. So we're going to get x to the minus 6. Now we're dividing. We've not acted on the division yet. And we get to this bit. But remember that we need to raise the 3 to a power of 3 as well. So we need to do 3 cubed, which is 27. And then we do this bit where we multiply our powers minus 1 times 3. So we've got x to the minus 3. So simplifying down further, you've got 216, and let's see if we can divide that by 27. Now, if you've got a bit of number sense here, you'll know that that will go in precisely. The reason being, we know about 216. We know that that is 6 cubed, and 6 you can write as 2 times 3. Apologies, it was 6 cubed, so there we go, 6 cubed. And you can cube these individually. So that's telling you that 216 is 8 times 27. So we know that 216 divided by 27 will be 8. You basically should have had perhaps had a sense that it would go in, because within 6 cubed they will be a 3 cube, so it should go in precisely. So that's 216 divided by 27, and then you've got x to the minus 6. We're dividing by x to the minus 3. The powers are the same, so we need to subtract our powers. So we need to be careful here. We've got minus 6. We're subtracting because of the division, but the other power is minus 3. So this becomes a plus. So it's going to be minus 3 there. Incidentally, we could write the x on the bottom. We can ditch that negative and write it as a nice x cubed on the bottom. Let's look at these problems. Just make that a bit bigger for a second. So there 27 is been raised to the power of 2 over 3. The 2 is basically saying, can you square me? Can you square the number? So 27 squared. And the cubed is saying, can you, sorry, the 3 is saying, can you also cube root me as well? Do those two things. Now, it's obviously better to do the cube rooting first to act on the 3, because then the numbers are going to be smaller. So all I'm going to do here is take 27, I'm going to get rid of that 3 by cube rooting 27. And of course the cube root of 27 is 3. So because I've cube rooted 27 now, I don't have to write that 3. I've just got the 2 there. And the 2 of course means that I square to give 9. In part B, there's going to be 3 jobs to do. I need to act on the negative sign, I need to act on the 4, and I need to act on the 3. And the best thing to do first is probably to act on the negative sign, just get that out of the way. Bearing in mind that this is 8 over 1 here, so the way that we act on the negative sign is to take the reciprocal, so we swap over our numerators and denominators. And in doing that, I no longer write the negative. That's a plain old 4 over 3. Do put things in brackets though. Next, we can act on the 4 if we wish, but I don't fancy doing 8 to the power of 4. So I'm going to choose to just act on the 3. And the 3, because it's on the denominator of that power, means we're going to be doing rooting. So we're going to take the cube root. So the cube root of 1 is 1, that doesn't change. The cube root of 8 is 2. So put this in brackets. I no longer need to write the 3, I've just got the 4 there. So finally I do 1 to the power of 4, 1, and I do 2 to the power of 4. Looking at C, again I'm going to choose to take the reciprocal of this number, which entitles me to dispense with that negative sign, which is a bit confusing. So I'm just raising that now to the power of 3 over 2. And again, the 2 is what you're going to act on next. That is asking you to square root the number, and we square root the top separately, and we square root the bottom separately. And bear in mind, when you square root, there is two possibilities of it being plus or minus. And now that we've square rooted, that's fine, but we still need to do our cubing, which is the last thing that we do. So we've got 4 cubed there, and we've got 3 cubed there, and we still have the plus or minus possibilities, because if you were to take something positive and cube it, it would still be positive, and if you were to take something negative and cube it, it would still be negative, because you've got an odd amount of negative signs. Finally, for D, you can see this is really quite difficult, because you've got a horrible mixed number. I really dislike that, and that is the clue of where to start. We don't want the mixed number, so let's make it an improper fraction. The power is not going to change, but of course in those two holes you've got 54 over 27, so 2 times 27, 54. Add the 10 means we've got 64. So I didn't like the mixed number, so we get rid of it. We change it to an improper fraction. I don't like the negative next, I want to get rid of that, so we flip it over, we take the reciprocal, so that entitles me to not bother with the negative now, and then we're going to act on the 3 next by cube rooting the top and cube rooting the bottom. Keep putting it in brackets, please. We've still got to raise to the power of 4. 3 to the 4, bear in mind that 3 to the 4 is the same as 9 squared, which is 81. Let me just show you where I'm getting that from. So 4 to the 4, we can do 4 times 4, which is 16, and another 4 times 4, which is another 16. So that's 256.